Welcome back to the deep dive. Today, we're tackling creatine. It's this compound that, well, it's legendary in sports science, right? But maybe also the most debated, the most misunderstood supplement out there.
Absolutely. For years, decades really, it was just seen as something for, the hardcore strength athletes, the power lifters,
Yeah.
often kind of mixed up culturally with more extreme stuff.
And that perception, that confinement, it really hasn't done the science justice, has it?
Not at all. I mean,
Yeah.
creatine is probably the most studied nutritional compound we have.
Mhm.
There are literally thousands of papers, and they confirm not just performance benefits, but its safety, its effectiveness, really across your whole life.
So our goal today, our mission for this deep dive, is to get past that old gym mythology. We want to unpack the actual science, this expanding evidence.
And we're starting right at the cutting edge with something pretty surprising.
Yeah, we thought we'd lead with what feels like the biggest aha moment in recent creatine research. So forget the bench press for a minute. New studies are showing creatine acts as a really potent cognitive enhancer, like for your brain.
It's genuinely a paradigm shift. We're seeing studies demonstrating this dramatic boost in thinking, especially when your brain is under stress. Think extreme fatigue, maybe pulling an all-nighter.
Wow.
Yeah, it confirms creatine is this universal energy buffer. It helps your brain, our most complex organ, just like it helps muscles during a workout.
Okay, so to make sure you, the listener, really get the full picture, we've pulled together insights from the top sources. We're talking the big position stands from the International Society of Sports Nutrition, the ISSM Plus major systematic reviews, and these newer groundbreaking studies.
We're aiming to reframe creatine, move it from just being a performance supplement to part of a bigger conversation about like fundamental health, whole body stuff, longevity even.
That really feels like the right perspective now. We'll dig into how it actually works biologically. We'll tackle all those myths that just won't die. And then, yeah, get into the latest on neuroprotection, aging.
It's a lot to cover, but it paints a fascinating picture.
Okay, let's unpack this. We really need to start at the beginning, right? At the cell level. Because understanding how creatine fuels the body, that mechanism, that's the key to seeing why its benefits are so broad. We often hear creatine called an energy buffer. It's a neat description, but can you walk us through what's actually happening, the enzymes, the process? How does creatine, or CAR, jump in during, say, a sprint? And what's this creatine kinase system doing?
Sure. It's an incredibly rapid system. So creatine's main job, metabolically speaking, is to grab onto a high-energy phosphate group, think of it as pi, and quickly form something called phosphocreatine, or PCR.
Okay.
And this whole reaction is driven by an enzyme called creatine kinase, CK. That's the heart of the creatine kinase phosphocreatine system. You might hear it called the CK-PCR energy shuttle.
Right, the shuttle. So you've got this PCR stored up inside the muscle cells, just waiting. Why is this system so crucial compared to, I don't know, just burning sugar through glycolysis?
Speed. It's all about speed. Glycolysis, oxidative phosphorylation. Those pathways are powerful, sure, but they're relatively slow to ramp up.
Okay.
When you explode into action, a heavy lift, a really fast sprint,
Yeah.
your demand for ATP, that's the cell's energy currency, just skyrockets. We're talking thousands of times higher than resting.
Wow.
The ATP you have ready in the cell, gone in maybe 1 or 2 seconds, max.
So fast.
That's where PCR steps in.
Huh.
It immediately gets broken down. That phosphate group gets ripped off PCR and slammed right back onto ADP. The used ADP instantly regenerating fresh ATP.
So the CK-PCR system isn't really making new energy from scratch. It's more like super fast recycling of the spent energy money. Buys you time.
Exactly. It's the highest power output, shortest duration energy system we possess. It keeps ATP levels high during those first few seconds of intense anaerobic work. Stops fatigue setting in quite so fast, lets you go hard for maybe, 8 to 15 seconds longer than you could otherwise.
That makes sense.
But it's actually a bit more sophisticated than just immediate ATP top-up in the main part of the cell, the cytosol.
Oh, really? How so?
Well, it also acts as a physical energy shuttle. A lot of the cell's ATP is actually made inside the mitochondria, the powerhouses, right?
Right.
But the energy is needed out in the cytosol where the muscle contraction happens. The CKP-PCR system actually helps ferry these high-energy phosphates from the mitochondria out to where the work is being done. It helps maintain the energy balance across the cell. It's almost like a communication network as much as a fuel reserve.
That dual role, the instant refill, and the transport system, that really clarifies why boosting creatine stores has such widespread effects. Okay, let's switch gears a bit. We have to address this common confusion. Creatine versus anabolic steroids. Because creatine builds muscle and strength, people still link them.
Yeah, that comparison. It comes from a lot of old misinformation,
Yeah.
honestly, and we need to be crystal clear here. Yes, the outcomes getting bigger, getting stronger might look a bit similar on the surface, but the chemistry, how they work, their legal status, totally completely different things.
And creatine is regulated completely differently, isn't it?
Absolutely. Creatine is a natural compound. Your body actually makes some itself in the liver and kidneys from amino acids.
Yeah.
In the U.S., it's regulated under DSHEA, the Dietary Supplement Health and Education Act of 1994. It's just a dietary supplement.
Like vitamin C or fish oil.
Pretty much.
Mhm.
There's zero legal issue with having it or taking it. You find it in supermarkets, pharmacies, everywhere.
Whereas anabolic steroids, that's a whole different ball game legally.
Oh, completely. They're drugs. Steroids have a very specific chemical structure based on testosterone. They work by binding to androgen receptors inside your cells, basically telling your DNA to build more muscle protein.
And the law treats them as drugs.
Yes, they're classified as Class C, Schedule III controlled substances, regulated by the FDA, the DEA. It's illegal to have them or use them without a doctor's prescription. One affects energy pathways and cell hydration. The other directly manipulates your hormones. Biologically, they're not even in the same ballpark. It's actually kind of amazing, isn't it? How science has had to keep pushing back against these creatine myths. They seem so resistant to the actual facts, especially the ones about safety.
Okay, let's tackle the big one first. The Mount Everest of creatine myths. The kidney concern. I mean, you mentioned creatine to some doctors, even today, and they might tell you to stop taking it because of your kidneys. Why is this particular myth so sticky?
It's really a case of biochemical guilt by association. It boils down to creatinine.
Creatinine, that's the breakdown product.
Right. Exactly. Creatine gets used, breaks down into creatinine, and your kidneys filter that creatinine out into your urine. And creatinine levels in your blood. That's the standard test doctors use to estimate how well your kidneys are filtering the glomerular filtration rate, or GFR.
Ah, I see where this is going. If you take creatine supplements,
You increase your total body pool of creatine, which means, naturally, you'll break down a bit more into creatinine, so your blood and urine creatinine levels will go up.
so a perfectly healthy person taking creatine shows higher creatinine, and if a doctor just sees that number in isolation without context.
They might think, uh-oh, early kidney problems, because high creatinine is usually a red flag. The initial scare stories came from a few, frankly, poorly done case reports back in the 90s.
That's what the science now. What's the consensus?
Unequivocal. The scientific consensus today, based on huge amounts of data, long-term studies, systematic reviews, it's crystal clear. They've tested high doses, like up to 30 grams a day, which is a lot for as long as 5 years, and they found absolutely no increase in kidney problems in healthy people. Zero.
Okay, but what about people who aren't perfectly healthy? Maybe someone with, say, diabetes. That's often where the doubt creeps in.
That's a really important question, and the research has gone there. They've done studies specifically in clinical populations.
Yeah.
People with type 2 diabetes, people with high blood pressure, folks who are already at higher risk for kidney issues.
Mhm.
Even in these groups, creatine supplementation didn't show any negative effects on kidney function markers.
Hmm.
Things like BUN and blood urea nitrogen or protein leakage in the urine didn't make anything worse. So the conclusion is really strong. If your kidneys are healthy to start with, creatine isn't going to harm them. The higher creatinine reading is just, well, it's an artifact of the measurement because you have more creatine on board.
That makes sense. But let's say someone listening is due for a blood test. Their doctor tells them to stop creatine beforehand. Doesn't that kind of prove it's affecting the kidneys?
Ah, that's the key practical point.
Yeah.
You don't stop because creatine is harming the kidneys. You stop because it interferes with how the test is interpreted. If the doctor needs a true baseline reading of your kidney function without that extra creatinine floating around from the supplement, they have to ask you to stop taking it for maybe a few days a week. Let the levels return to your normal, non-supplemented baseline. It's purely about getting an accurate reading, not about preventing damage.
Got it. Okay, let's move to myth number 2, the hair loss one. This often gets linked to DHT, dihydrotestosterone.
Right, this one's interesting because you can trace it back to basically one study. A single paper by Van der Merwe and colleagues from 2009 looking at rugby players.
And DHT, that's the testosterone metabolite, sometimes linked to male pattern baldness if you're genetically prone.
Exactly. So what did this one 2009 study actually find?
Tell us.
They had the players do a loading phase 25 grams a day for a week, then a maintenance dose of 5 grams. They found that DHT levels went up by about 56% during loading and stayed about 40% above baseline during maintenance. And they reported this as statistically significant.
Okay, statistically significant. That sounds, well, significant. Where did the interpretation go wrong?
It went wrong in a few key ways. First, The study found absolutely no change in the player's total testosterone levels. DHT comes from free testosterone. All right. Second, even with that 56% jump, the actual final level of DHT, it remained well within the normal clinical range for healthy young men. It didn't push anyone into some kind of super high problematic zone.
So statistically detectable, maybe, but biologically probably not meaningful.
Pretty much. And third, and this is crucial, when people looked closer at the study later, they noted the creatine group actually started with a slightly lower baseline DHT level than the placebo group.
Ah, so the percentage jump looked bigger than it might have otherwise.
Exactly. And since then, we've got about 12 other studies looking at creatine and testosterone. Only 2 found tiny temporary bumps in total testosterone that weren't really physiologically significant.
Yeah.
5 studies specifically measured free testosterone, the direct precursor to DHT, and found no increase at all.
So it really seems like one single study, maybe misinterpreted or overblown, created this lasting fear. And the bottom line, has any study ever actually reported people losing hair or going bald because of creatine supplements?
Not one. 0. It remains purely anecdotal fear, mostly online, not backed by research on humans.
Okay, good to clear that up. Let's talk about the more immediate things people sometimes report. Water retention, maybe cramping. Does creatine make you look bloated or increase your risk of cramps, especially in the heat?
Okay, water retention. Yes, creatine does increase total body water. That's part of how it works physiologically. But where the water goes is key. Creatine primarily pulls water intracellularly inside the muscle cell. It does this through osmosis.
So it makes the muscle cell itself fuller.
Right. That's what gives muscles that fuller, denser look, some people notice. It generally does not cause significant extracellular water retention, the kind under the skin that makes you look puffy or bloated. That's a different mechanism.
That makes sense, pulling water into the engine, so to speak.
And as for cramping, the data actually points the other way. Study after study shows creatine supplementation does not increase muscle cramps, strains, or injuries.
Really? The opposite.
Yeah, in fact, because it helps pull water into the cells, this hyperhydration effect, creatine might actually improve an athlete's tolerance to exercising in the heat. It could potentially reduce the risk of heat-related problems. Clinically, it's even been used to help reduce muscle cramps in patients undergoing hemodialysis.
So where did the cramp myth come from?
Probably from athletes doing really intense loading phases, maybe not drinking enough water overall, and then blaming the creatine when they cramped up. Bad hydration protocols, basically, not the creatine itself.
All right, myths busted. Let's get back to the positive side, the expanding benefits. We know it boosts short burst power, but how does creatine help someone like an endurance athlete, or even just help with everyday recovery from exercise?
Yeah, the endurance benefit is maybe less obvious, but it's definitely there, mainly through how it impacts glycogen.
Glycogen, that's our stored carbohydrate fuel, right? For longer effort.
Exactly. And when you take creatine together with carbohydrates or a carb-protein mix, studies consistently show you store significantly more muscle glycogen than if you just had the carbs alone.
Whoa, really? So creatine helps you kind of super compensate your fuel stores. Why does that happen?
The thinking is it's partly due to maybe some insulin sensitizing effects of creatine and partly just the physics. The osmotic pull of creatine bringing water into the cell might also help draw more glucose in with it.
Oh,
Whatever the exact reason, this boosted glycogen storage is huge for recovery,
how so?
especially for athletes training hard day after day. It helps refill those muscle tanks faster, fights off depletion, and that can help prevent overtraining syndrome. You can handle more volume, recover better.
Okay, that's glycogen. What about recovering from the actual damage of hard exercise? Like after a long run or a really heavy lifting session, how does creatine help the muscles repair?
It seems to speed things up by reducing markers of muscle damage. When muscles get damaged, they leak certain enzymes out into your bloodstream. Scientists measure these things like plasma creatine kinase, that same CK enzyme again, and another called LDH.
Right?
Studies show that taking creatine significantly lowers the amount of these damage markers you see in the blood after really tough workouts, like running 30 kilometers or doing intense bodybuilding training.
Less leakage means less damage, less inflammation maybe, faster return to feeling good.
That's the idea. It seems to help stabilize the muscle cell membrane, making it more resilient, so less damage occurs in the first place. And that translates directly into less muscle soreness and better ability to maintain your strength in the days following hard training. It helps you tolerate higher training loads more safely.
This idea of tolerating more, recovering better, it feels incredibly relevant when we think about aging and that fight against sarcopenia.
Oh, absolutely. Sarcopenia, that gradual age-related loss of muscle mass, strength, and just general function, it's probably the single biggest driver of losing independence and becoming frail later in life.
Right.
And creatine, it offers really solid benefits for older adults, especially when they combine it with resistance training.
What kind of specific improvements do seniors see?
Well, definitely increases in muscle strength, how much they can lift. But maybe more importantly, improvements in functional capacity. Real-world stuff,
Like what?
like better balance, walking faster, being able to get out of a chair more easily, and also a delay in neuromuscular fatigue, meaning they can do their daily activities for longer before getting tired out, keeps them more active, more independent.
You mentioned body composition benefits too, beyond just muscle gain. For older folks,
Yes, it's not just about muscle. The effect seems synergistic. There was a key meta-analysis by Forbes and colleagues looking specifically at adults 50 and over. They found that the older adults taking creatine while resistance training didn't just gain more muscle, they also saw a greater reduction in body fat percentage.
really, they lost more fat.
Yeah, on average, the creatine group lost about half a kilogram, roughly a pound more fat mass, than the placebo group doing the exact same workouts. It seems creatine helps optimize the body's response to the training stimulus in older individuals.
So supporting muscle growth and helping regulate metabolism and body fat, that's powerful.
And we can't forget bone health. This is crucial, especially for postmenopausal women. Creatine, again, when combined with resistance training, seems to help increase bone mineral content and density.
How significant is that?
Well, one study looked at bone mineral density, BMD, specifically at the femoral neck, that's the top of the thigh bone, in the hip area, a really common fracture site. They found the older adults taking creatine lost significantly less bone density there compared to the placebo group, even though both groups were doing the same exercise program.
Wow. So it's actively helping preserve bone alongside building muscle. It's like this multi-system shield against some key aspects of aging.
That's a great way to put it, a multi-system shield.
Okay, this is where, for me, it gets really fascinating. We're moving beyond the muscles entirely now, right into the brain. We know creatine buffers energy and muscle. How does that same principle apply to our, central command center?
Well, the brain is just incredibly energy hungry. It's only about 2% of our body weight, but it burns through something like 20% of our resting energy, nonstop.
Oh.
And just like muscle cells, neurons rely heavily on ATP. And guess what? They also use that same CK-PCR system to buffer their energy supply, to keep ATP levels stable. So when the brain is under stress, maybe low oxygen, maybe intense mental effort, or especially sleep deprivation, its ATP demand surges, and having good PCR stores becomes absolutely critical.
Okay, let's zoom in on that German study you mentioned earlier, the one looking at cognitive boost during fatigue. Keeping people awake for 21 hours? That sounds like a pretty extreme test.
It was definitely a demanding study design, but they needed to induce a state of significant metabolic stress in the brain. So yeah, volunteers awake for almost a full day. Then they were given a single, pretty hefty dose of creatine, 0.35 grams per kilogram of body weight.
That's a lot in one go for most people.
It is an acute large dose.
And what happened? What specific brain functions improved and how fast?
The results were striking. Just 4 hours after taking that single dose, the creatine group performed significantly better than the placebo group on a range of cognitive tests. We're talking things like working memory, logical reasoning, complex reaction time.
So executive functions, the stuff that usually tanks first when you're exhausted.
Exactly. And they backed it up with brain imaging. Using phosphorus magnetic resonance spectroscopy, it's a type of MRI that can measure energy molecules. They could literally see less evidence of that low energy fog in the brains of the creatine group, less metabolic stress.
So the creatine did exactly what it does in muscle. It rushed in to top up the high-energy phosphate reserves, keeping the brain's machinery running better, even when it was basically running on fumes.
That's the beautiful conclusion, yeah. And it kind of validates those old anecdotes you'd hear from powerlifters back in the 90s saying they felt mentally sharper on creatine, not just physically stronger.
So the theory is, when the brain gets tired, its creatine transporters kick into high gear and just grab that big dose.
That seems to be the thinking. Fatigue triggers this biochemical switch, makes the neurons extra hungry for creatine to replenish those critical PCR stores.
Amazing. Now, beyond just fighting off tiredness, the research is pointing towards some serious, maybe even life-saving neuroprotective benefits, right?
Absolutely. The evidence, especially from preclinical animal models, is really compelling here. Creatine supplementation consistently shows neuroprotective effects in various neurological insults.
Like what kind of situations?
It's been shown to reduce the severity of damage after spinal cord injury, after cerebral ischemia, that's tissue damage from lack of blood flow, like in a stroke, and perhaps most relevant for many listeners after traumatic brain injury or TBI, concussions.
That has massive implications for contact sports, obviously. Is the scientific community taking notice of this?
They are. The findings are consistent enough, it seems. Creatine helps stabilize mitochondria, reduce cell death after injury, that the International Society of Sports Nutrition, the ISSN, actually put out a recommendation.
Yeah, what did they recommend?
They recommended that athletes in sports with a high risk of concussion, or TBI, should consider habitual creatine use specifically for its potential neuroprotective effects.
So taking it before an injury happens as a sort of pre-treatment shield.
Exactly. The idea is to have those brain creatine stores topped up. So if an impact does occur, the brain might be better equipped to handle the metabolic fallout and mitigate some of the damage.
That totally reframes it from just performance enhancement to actually safeguarding the brain. Okay, let's shift focus slightly again. We need to talk about a group often underrepresented in early sports science, females. How does their specific physiology interact with creatine?
This is a really important area, and yeah, we can't just assume findings from studies on men applied directly. One interesting point is that females might actually have slightly higher baseline creatine concentrations within their muscle relative to their total muscle mass, which is generally lower than males.
And that might explain.
It might partly explain why some of the early performance studies in women showed maybe less dramatic initial results compared to men. They might have started from a slightly higher baseline saturation point relative to their muscle volume.
But the need for creatine, or how the body handles it, that changes dramatically across a woman's life, doesn't it, because of hormones?
Precisely. Creatine metabolism, how it's made, stored, used, is significantly influenced by the big hormonal shifts throughout the female reproductive lifespan. We're talking during the menstrual cycle, pregnancy, the postpartum period, perimenopause, postmenopause.
How do hormones affect it?
Well, the enzymes involved in making creatine, especially creatine kinase, seem to be sensitive to estrogen and progesterone levels. Estrogen, for example, appears to generally promote creatine storage. So you have these predictable times when creatine needs or utilization might change, and when supplementation could be particularly beneficial.
And that hormonal link, it extends to the brain, too. We see differences in brain creatine levels between sexes.
We do. Research shows females tend to have lower baseline creatine levels in certain brain regions, particularly the frontal lobe, compared to age-matched males.
And why might that matter?
Well, there's a hypothesis linking this to differences in susceptibility to certain mood disorders. We know, for instance, that depression rates are roughly twice as high in women during their reproductive years. So researchers are now actively looking at whether boosting brain creatine levels, boosting cerebral PCR through supplementation, could impact mental health.
What are they finding there? Any link to mood?
The initial findings are quite promising. Higher brain PCR levels seem to be inversely related to depressive symptoms. There was one really interesting study on adolescent girls who weren't responding well to standard antidepressant medications, SSRIs.
Okay.
When they added creatine to their treatment regimen, they saw a significant reduction in depressive symptoms. It suggests that maybe, for some individuals, inadequate brain energy supply bioenergetics might be playing a role in their mood disorder.
So whether it's muscle, bone, brain protection, or even potentially mental health, creatine seems to be this really fundamental nutrient, especially important during times of hormonal change or high metabolic demand across a woman's life.
That's definitely the picture emerging from the latest science. It's much broader than we used to think. Right, so with all this compelling evidence, the obvious next question is the practical one. Okay, how should someone actually use creatine effectively? We need to cover dosing strategies, how to get saturated, and something absolutely crucial, the quality and purity of the supplement itself.
Let's start with dosing. We always hear about the loading phase. Is that 5 to 7 day period of taking a lot really necessary, or is it just about getting results faster?
It's purely about speed, getting saturated quicker. The loading phase is the fastest way to max out your muscle creatine stores. You typically increase them by about 20% to 40%.
And how much is that usually?
The standard protocol is 20 to 25 grams per day, taken for 5 to 7 days. And you'd usually split that dose up, maybe 4 or 5 separate 5-gram servings spread throughout the day. That helps with absorption and avoids potential stomach upset from taking too much at once.
Okay. And is there a more precise way to calculate the loading dose, maybe based on your size?
Yeah, for people who want to be more exact, the ISSN suggests basing the load on body weight,
Right.
about 0.3 grams per kilogram of your total body mass per day.
So, quick math. An 80-kilo person, that's 80 times zero point 0.3, 24 grams a day for that first week.
Exactly.
But what if someone wants to skip that? Maybe they're worried about the temporary water weight gain that sometimes comes with loading or just don't want to take that much. How long does the slower, more gradual approach take?
You can absolutely skip the load. The gradual approach is just to start taking the standard maintenance dose right from day one, so typically 3 to 5 grams per day.
Mm.
If you do that consistently, you will eventually reach the same maximal muscle saturation level. It just takes longer.
How much longer?
About 28 days, so roughly 4 weeks, compared to the 1 week with loading. Both methods get you to the same place eventually. One's just faster. Long term, they're equally effective.
Okay, so once you're saturated, either through loading or the gradual way, what's the daily dose needed just to maintain those high levels?
Once you're saturated, your body just needs to replace the small amount of creatine that naturally gets broken down and excreted each day. For almost everyone, a daily dose of 3 to 5 grams is plenty to keep those muscle and, importantly, brain stores topped right up indefinitely.
Right, now, the supplement aisle.
Yeah.
It can be confusing. You see creatine monohydrate, sure, but also creatine ethyl ester, buffered creatine, liquid creatine. Do any of these fancy, often more expensive forms actually work better than the plain old standard?
This is where you really need to follow the science, not the marketing hype. The recommendation from researchers from the ISSN is simple and consistent. Stick with creatine monohydrate, just CM, because it's the form that has been studied relentlessly. Thousands of studies prove its effectiveness and safety. And crucially, rigorous reviews comparing it to these other novel forms have consistently found that they are not superior to basic creatine monohydrate. They don't lead to higher muscle creatine levels, they don't improve performance any better, and they aren't safer.
Can you give an example? One of those alternatives that didn't live up to the claims.
Yeah, a classic one was creatine ethyl ester, or CEE. It was marketed really heavily for a while, claiming better absorption, less bloating.
I remember that one.
Right. But when scientists actually tested it, they found CEE actually broke down into creatinine, that inactive byproduct, much more easily, sometimes even faster than regular CM, especially in liquid. And in training studies, it showed zero advantage over basic monohydrate for building muscle or strength. These newer forms are often just attempts to create a patent or a marketing edge, not real scientific improvements.
So the message is clear: stick with creatine monohydrate. But you mentioned purity within monohydrate is critical. How does a regular person ensure they're getting a high-quality, pure product?
Purity is probably the single most important factor after deciding on monohydrate. You absolutely want to source a high purity product. Generally, creatine monohydrate sourced from Germany, often marketed under brand names like Crepure, is highly recommended
Why German-sourced specifically?
because their manufacturing processes are incredibly stringent and typically yield a product that's around 99.9% pure creatine monohydrate. Very few contaminants.
And what are the risks with less pure creatine? Where might that come from?
Well, concerns have been raised about creatine manufactured in places with less rigorous quality control, potentially some sources from China, for example. Testing has sometimes found unacceptable levels of unwanted byproducts.
Like what kind of contaminants?
Things like dicyaniamide, which is a chemical left over from some manufacturing rounds. Sometimes higher levels of creatinine itself, meaning you're paying for less active creatine. And most worryingly, a compound called dihydrotriazine.
What's that?
It's structurally similar to some known carcinogenic compounds. And besides chemical contaminants, poor processing can also lead to contamination with heavy metals, like mercury or lead.
Yikes. Okay, so looking for that German sourcing or third-party purity testing certifications on the label is really important for safety.
Absolutely vital. It's not just about effectiveness, it's a health and safety issue.
Definitely. Okay, last practical point. This debate about timing. Taking creatine right before your workout versus right after. Does it actually make any real difference?
The timing question. This is probably the most overanalyzed, least important aspect of creatine use for most people.
Really?
Well, we do know that exercise itself seems to help your muscles take up creatine a bit better. Probably because of increased blood flow during and after the workout, and maybe increased activity of the pumps that transport creatine into the muscle cell.
So logically, you'd think taking it around the workout pre or post would be best?
That's the theory, yes. But when you look at the actual studies trying to compare immediate pre versus immediate post-workout timing, the evidence is really Well, messy. It's conflicting.
How so?
There were a couple of small early studies, one often cited one in particular, that suggested maybe, possibly, taking it post-workout led to slightly greater gains in lean mass or strength. But the differences were tiny, honestly, probably not practically meaningful. And the studies themselves had limitations, maybe weren't statistically powerful enough. Later reviews found the evidence just isn't clear or strong.
Why is it so hard to pin down, if the theory makes sense?
Because creatine doesn't work like, say, caffeine, where the acute timing matters a lot. Creatine works by chronic saturation. The benefit comes from having your muscle stores consistently full, 24/7.
Ah, okay.
So whether you took today's 5 grams an hour before your workout, or right after, or even 8 hours later, your muscles are still essentially 100% saturated from all the previous day's doses.
Yeah.
Those tiny potential uptake differences around the workout, they likely get washed out over weeks and months of consistent use.
So the bottom line for someone just wanting the benefits.
Don't sweat the timing, seriously. Focus on consistency. Just make sure you get your 3 to 5 grams in sometime each day. That's what matters. The pre versus post debate, not really supported by solid evidence, is a major concern right now. Just take it when it's convenient for you. Hashtag tag outro.
Wow, okay, this deep dive has really, I think, fundamentally repositioned creatine. We've moved way beyond just thinking of it as fuel for lifting weights. We've established it's this critical piece of our whole body's energy system.
Yeah, safely boosting recovery, helping maintain muscle, even supporting bone health as we age. It's pretty remarkable.
And then there's the brain aspect, maybe the most exciting part. Confirming that scientific basis for it acting as a neuroprotector, as a cognitive booster, especially when we're stressed or tired.
The science really is definitive now. We have to get past that old view of creatine as just for bodybuilders. It's arguably one of the most effective, safest, and, let's face it, most cost-effective nutritional tools we have for optimizing how our body uses energy, right down to the cellular level.
This shift in understanding, it almost forces us to think about it differently. You mentioned neuroprotection against TBI, against concussion. You talked about fighting sarcopenia, bone loss. If we connect those dots,
Yeah.
it starts to sound less like an optional supplement and more like, I don't know, a foundational nutrient, something that could have real public health implications, maybe like ensuring people get enough vitamin D or omega-3s.
That's exactly the conversation we should be having. The evidence is strong enough to suggest that ensuring consistent, low-level intake, maybe just that basic 3 grams a day throughout life, particularly during vulnerable times like aging or high-stress periods, it could offer significant long-term preventative health benefits.
Protecting physical function, protecting cognitive resilience as we get older.
Precisely. Moving it from the performance niche to foundational health.
So what does this all really mean for you listening? The science is clear. That energy boost creatine provides. It's far more fundamental, far more widespread than most of us ever thought. Go forward and be well informed.